Hello, good people. Welcome back to another episode. Today's title is very fascinating one, and the title is The Science and Beauty of Rain. So, what is rain? Rain is a form of precipitation, any water that falls from the atmosphere to the earth's surface. It occurs when water vapor in the atmosphere condenses into droplets. These droplets collide and grow larger until they are too heavy to stay suspended in the air, and then they fall, and that's the rain. But why does water condense in the first place? This happens when warm, moist air rises and cools. As it cools, the water vapor it holds begin to condense around tiny particles in the atmosphere, like dust or sea salt, forming clouds. When the droplet in this cloud become large enough, gravity pulls them down as rain. The global cycle. Rain is a central component of a water cycle, also known as the hydrologic cycle. Water evaporates from oceans, lakes, and rivers, form clouds, and falls as precipitation. That precipitation either seeps into the ground, flows into rivers, or returns to the sea. Globally, over 5 lakh cubic kilometers of water falls as precipitation each year. That's enough to fill nearly 200 million Olympic sized swimming pools every year. Regions around the equator, like the Amazon or parts of Southeast Asia, experience high rainfall due to persistent convection, the upward movement of warm moisture. In contrast, deserts like the Sahara remain dry because of descending air currents that inhibit cloud formation. Now I'll discuss about the types of rain. This is so that not all rain is the same. Scientists categorize rain based on intensity and formation process. Stratiform rain. This is widespread and gentle, formed by large layered cloud called stratus. It often lasts for hours and provides steady moisture to the land. Convective rain usually associated with thunderstorm. The rain is more intense and localized, forming from cumulonimbus clouds. It can cause flash flooding due to its intensity. Orographic rain occurs when a moist air is forced to rise over mountains. As it rises, it cools, condenses, and rains, often on the windward side, while the leeward side remains dry, creating what's called a rain shadow. The most important part of our rain is the chemistry of rain. Rainwater is not just pure water. As it falls through the atmosphere, it can pick up particles and gases. Sometimes this is harmless. Rain might create dust or sea salt, but in industrial regions, rain can absorb sulfur dioxide and nitrogen oxide, forming acid rain. Acid rain has a pH of lower than 5.6 and damage crop, forest, and aquatic ecosystem, and most importantly, the color of building. Though air quality regulations in many countries have helped reduce acid rain, it's still a concern in a region with heavy industrial activity. Rain and human culture. Beyond science, rain holds a special place in human culture and psychology. It's often seen as a symbol of renewal, sadness, or romance. In literature, film, and music, rain is used to set moods and mark emotional turning points. Interestingly, studies show that weather can affect mood, with rainy weather sometimes linked to low energy or mild depression symptoms, especially in people sensitive to sunlight exposure. But it's not all negative. For many, rain provides a sense of calm. The sound of rain, often used in sleep apps, is known to promote relaxation and even help with anxiety. There is many uses of rain in our daily life, but in particular places like agriculture, the usefulness is over explained. From a practical standpoint, rain is essential for agriculture. Crops rely on seasonal rain, and farmers around the world depend on predictable rainfall patterns. But with climate change, those patterns are becoming less reliable. In some places, rainfall is becoming more erratic, leading to both drought and floods. These not only threaten food security but also increase economic and social instability in vulnerable regions. Advanced forecasting, irrigation system, and water management technologies are becoming more important than ever to adapt to these changes. Let us try to listen another part of our rain. This is physics of rain, how it forms, falls, and behaves. Rain begins high in the atmosphere. Water vapor condenses into tiny droplet and small particle like dust or salt. This process releases latent heat, which helps fuel cloud formation. When enough droplets come together, they grow larger through a process called coalescence. Eventually, the droplets become too heavy to stay suspended in air, and gravity pulls them down as rain. But why the raindrops fall at different speed? That's due to balance of gravitational force pulling them down and air resistance pushing up. Smaller droplets fall more slowly, about 2 meters per second, while larger ones can reach up to 9 meters per second. However, once a drop reaches about 5 millimeters in diameter, air resistance causes it to break apart into smaller drops. Did you know raindrops aren't actually tear-shaped? Due to air pressure as they fall, small ones stay nearly spherical while larger ones flatten into a hamburger bun shape. Temperature plays a key role too. If it's below freezing high up in the cloud, rain can begin as ice or snow and melt into liquid before hitting the ground. So, in short, the physics of rain involve condensation, coolness, gravity, air resistance, and thermodynamics all working together in the sky to create the drops we feel on Earth. So, what is the future of rain in a changing climate? Climate scientists project that a global temperature rise, the water cycle is intensifying, warmer air holds more moisture, which can lead to heavier rain events. In fact, many regions are already experiencing more intense storm and greater rainfall extremes. This doesn't mean every place will get wetter. Some areas may become even drier. A shifting wind pattern and ocean currents alter precipitation distribution. Rain, which has long been used as a source of life, cloud increasingly become a source of challenge in the 21st century. Well, the final thoughts, rain is both ordinary and extraordinary. It's something we often take for granted, but it plays a crucial role in maintaining life on Earth. From feeding crops to filling reservoir, shaping ecosystem to influencing our moods, rain is a silent but powerful force. So the next time you hear the soft rhythm of rainfall on your window, maybe take a moment to appreciate the complex science and deep beauty behind its drop. Thanks for listening to today's episode. Stay curious.